Hi everyone, welcome to the AllThingsXR podcast. I'm Mojtaba. After a long while, I'm back with another episode about NeRFs, neural radiance fields. My guest today is Jonathan Stevens, one of the most popular experts in this field. His tutorials have been featured by NVIDIA and his videos are the golden standard in this field. Enjoy. So, Jonathan, welcome to the All Things XR
Thank you.
podcast. For those of our
Welcome.
listeners who have already worked with nerves, I'm sure they know you, but for those who haven't, can you introduce yourself and tell us more about your background?
Yeah, my name's Jonathan Stevens, and yeah, I've been diving into NeRFs for the past about a year now. Uh, my background actually is around. I started in geospatial GIS world, and then I about a decade ago moved into computer vision, 3D reconstruction, and from there I've done solutions consulting, marketing, uh, market discovery, and now more developer advocacy and being more of a technology evangelist for a computer vision company. So part of my job is just showing people what is possible and helping them understand some of this new technology that sounds scary is actually not very hard to use or implement in application. So that's kind of my background in a very short amount of time. So that's why I really dove into NeRFs. I saw it's something new and thought, boy, this is something I want to learn about, but I'm going to share with everyone else to kind of demystify it.
Great. So, Jonathan, what are nerves?
So NeRFs, I've been working on this explanation for a while. It's a very visual heavy medium to describe. It's like what's describing what a 3D model is in general. But I started stealing an analogy that one of the original researchers on the very first NeRF paper used when I talked to him. And what a neural or NeRF is, it stands for what's called a neural radiance field, which again sounds kind of scary as a term because they're big words. But I like to use the analogy of if you wanted to describe a scene in the real world, there's multiple ways to do it. We're all used to, if you come from, let's say, computer graphics, from 3D modeling, you typically are describing it in a mesh with textures over it. And, or I come from a computer vision company where we also use a lot of point clouds. But a NeRF is a novel way, a different way to describe the appearance of a real world scene. And what they do as an analogy of it is imagine if you had a scene and you represented that scene as a Minecraft scene, as a bunch of cubes, and everyone knows what Minecraft is by now, uh, but there's a huge limitation, right? So if you want to model this room I'm in, or you're in, or anyone's listening is in, if they look around the room and think, boy, this room wouldn't look anything like this as a Minecraft version because the blocks are so big. Well, imagine if you took those blocks and then you reduced them to a very, very tiny little size. So small that you don't really see individual blocks. It's just like atoms or pixels in a scene. And that's what we've done. But the problem with doing that, and that's called a volumetric representation, where every point in space in a given area is a little cube. If you took that and you made, let's say there's billions of these cubes in what represents maybe just your room, your office, or your bedroom, or your house, it would be a massive file size. So your computer couldn't handle it, or it would just be too slow. It wouldn't work. So that would be gigabytes of data just to represent a small scene. Well, that's where neural networks come in handy. And you're able to train a neural network to describe all those little blocks and where they belong in space and compress it to a very small file size where maybe even using a mesh, if your listeners are used to thinking of 3D assets as meshes to model a home or model a scene might be gigabytes of mesh triangles and textures. Well, imagine reducing that down to 100 megabytes. And that's what's a neural network. So that's the neural part of a neural radiance field. And then now these cubes that you're looking at in a scene, just describing the scene. Well, in the real world, if I look at my desk and it's got a little sheen to it, And depending how the light is bouncing off that desk from out my window here, it might be a light brown, but then maybe as you move, it turns colors a little bit, or you just see that reflectance or specularity. Well, that is also encoded in those little blocks and they're called view dependent. So those little blocks emit a color, a radiance. So you got your neural radiance field, and there's a field of them. So there's a whole defined area of these little blocks that have a color and intensity. And that is basically view dependent. So if I look at something from one direction and then move a few feet over and look at it a different direction, the color on that little point in space may look slightly different just because the light properties of the room are different from different angles on those objects. And so that's what a neural radiance field is doing, is you're able to see this volumetric representation of a scene. And instead of just modeling surfaces, every part of the scene is modeled. So like you can imagine fog gets modeled, things like that. And as you change your view through the scene, every time you change your viewpoint, is asking the neural network, okay, what is it supposed to look like from that direction? And then it'll render a new scene. And that's happening at a high frequency. So I think, 24, 30 frames per second, you could do that. And then look at a scene in a fairly close to photorealistic, way as possible. And that was the original intent of NeRFs. It's called view synthesis. It wasn't to 3D model surfaces. It was to approximate viewpoints as accurately as possible from viewpoints you've never seen. So that's the beauty too for a NeRF. I can take 100 photos of the room and then look at it from 1,000 different new locations, and it'll do its best to approximate what that view looked like between the sparse set of photos you had. So it's a very visual thing but if you, with that description in mind, and go look at some NeRFs online, they're flooded on the social media nowadays, you might have a better understanding what you're seeing. Think of it as like a extremely dense point cloud in which each point in the point cloud can change colors depending on which direction you're looking at, and even transparency. So that's how you get like window effects, where you're looking at a window and you're seeing through the window, but the window will bend light, change colors of whatever's behind it.
Great. So, Jonathan, is it necessary to be an AI specialist to use and create NeRFs?
So when NeRFs are only 3 years old, so that's brand new. If you think about, even photogrammetry has been along for a long time, and computer version of photogrammetry is about 30 years old. This is 3 years old. So at the start, this was basically, it still is, a lot of it is open source projects where you don't necessarily have to be a scientist to use this, but it was not easy. However, there's a few different companies who have made it very tangible for, let's say, just a creator, someone who doesn't have an AI or machine learning background or computer science background. Maybe they just want to make cool animations or, render some cool fly-throughs of a scene. They can now use, there's Luma AI, which is a commercialized option out there, and it's very easy to use. You just need a camera, or they have an iPhone app, and it's all through the web. If you don't have an iPhone app, where you can easily create NeRF renderings and animations around a NeRF rendering or over a NeRF model here. There's Hapier has a company that made called Capture, is an app for an iPhone that has a 3 instead of an E. And then even NVIDIA's, they're the first company to speed up NeRFs, because it used to take on the order of magnitude of about 3 days to train a neural network and then render a small video. Well, they managed to reduce that down to 3 minutes or 4 minutes, depending on what GPU you have. At least on my GPU, it takes a handful of minutes to render that all. And they've made executables, so now you don't have to be a machine learning scientist or a computer scientist to compile code, and you can just use the Windows executable. And then on my side, I even made a few videos to kind of help people along with those executables, because there is a few steps that seem a little daunting, but I've turned them into batch files where you can just drag images in and you're on your way. So yeah, it's definitely opening up very quickly for content creators.
Yeah, your videos and your tutorials are the best, I think. Even
Yeah.
NVIDIA has covered those, yeah?
Yeah. So NVIDIA very early on after Instant NGP is what they call their fast NeRF framework. When that came out, I really was, oh, okay, this is something I can actually do on my PC. I don't have to wait. I don't have to let my PC process data for 3 days before I find out if I even did it right. I could find out in minutes. And then I said, I'm going to make a tutorial on how to do this. And I think I prepped for maybe 20, 30 minutes. It was just kind of like I'll just make this for myself as well. Put it on our company's YouTube channel, put it on Twitter. And then they reached out very fast and said, hey, can we put this on our technical blog? Can we put this on so they quickly been picking up my tutorials because I think I don't know what I do. I just make them for myself more than anything, but I make it easy. I don't get too into the weeds. I try to just kind of say, well, I actually live stream them. I don't edit them. I just kind of walk you through the process in real time. And I think that's what people sometimes need. Like I see people say, well, I'm going to show you how to make. There's one called NeRF Studio. I love it. Their first video on how to use it was 4 minutes long. And if you've never, and that one requires Python, and I mean, they've made it easy for most people who are computer savvy, but they still skipped over the fact that you need to know command line, you need to know a little bit of something. And they thought, oh, this is great, only 4 minutes. But I think people really wouldn't mind a 1 hour video if it literally walked them through why am I typing in this command, what it's doing, and that's why I've gotten so popular, I think.
Great. So, Jonathan, what do you think will be the effect of NeRFs in content creation industry, movies, 3D generation, and etc.?
Yeah, so I'm really excited about the future of what this brings for creators. There's kind of two purposes for it in my mind. One being for content creators, the other one being for machine learning scientists and people who want to do more science-based applications. For content creators, what's been very exciting about NeRFs is it's gotten so easy with applications like Luma AI where you don't have to even run. I mean, that runs on a cloud somewhere, so you don't even have to buy new hardware. So you can still kind of get the benefits of NeRFs without having to buy a lot of hardware. But also, I'm seeing that like NeRF Studio has now a plugin, or I don't think it's a plugin, but they have instructions how to get it in Blender. I'm seeing people putting it in Unreal Engine, Unity. I've gotten NeRFs running in Unity with my Oculus, so it's kind of opening up these. The problem early on was there's no interface between a NeRF and creative tools, and so now they had a few. Being NVIDIA has a GUI for theirs where you can make animations, but what people really want is I want to take it into my software, Blender, Unreal Engine, some sort of animation, perhaps software, do virtual cameras, mix in some 3D assets from, let's say, photogrammetry, and then really get neat scenes and neat effects. And I'm really starting to see that starting to blow up as a thing people can do. Even though it's early on, I think this is going to really evolve. I think for creators, it's really neat because you could let's say NeRF a scene of a room, and then you could put a real actor in there. I mean, the quality of NeRFs aren't quite there yet, but you could even use it. I went to an Infinity Festival, it's a film festival. People saw it is, what if I had a virtual version of the room that I sent a scout to? They took a bunch of photos. We trained it into a NeRF of this room, or I like even better an outside scene, because a NeRF doesn't just train like what's right around you, like in photogrammetry, where you get like just the objects that you're close to. It'll get everything out to the mountains and the sky and the hills, the clouds. It's all in there. And then you could do like a virtual shoot remotely and kind of get an idea of, okay, what's the light bounce at this time of day? What does it look like for, plan out your shoot. You have a lot more site information. And again, you also get like, let's say there's a lake in the background. You would get the light bounce trace of the reflections of the lake as you move through the scene in a NeRF, in a virtual camera environment, and kind of okay, well, if I want to do the scene, I want to follow this person. What does it look? They could probably do a lot of pre-planning before they actually show up on site, and the cost of filming goes way up. So, yeah, and just visual effects artists. I'm already seeing that. McDonald's had their first ad with a Nerf. If some people saw that, one of my favorite. I like running, so my favorite running YouTube personality, where he takes shoes and his name's the Ginger Runner. He started using Nerfs as just fun little reels to get people interested in watching his upcoming review, and he puts them on Instagram. They're just cool and interesting. So it is a elaborate fly through of a shoe that you would never be able to get with just, a camera. You would have to have like a robotic arm to get that kind of fancy shot. And it's just kind of neat.
Awesome, great. So, Jonathan, as you mentioned, before NeRFs, there were different methods of photogrammetry. Even Apple has some efforts in this field with reality capture. What do you think is the main difference between NeRFs and photogrammetry?
Okay, so that's a really good question, and I would like to describe this in more detail in some videos, but I think what early on I keep seeing when I've been posting NeRFs for, this is only useful once I'm able to get a mesh out of it. And they are missing the fact that a NeRF is never a mesh. It's a radiance field. It's a volumetric representation versus a photogrammetry is creating. If I want to describe this room, it's a bunch of triangles, and then you map some textures on those triangles, and what you're doing in photogrammetry is you are figuring out, you're triangulating surface points, and then you're turning them to a bunch of optimized triangles to describe something. And so it's just inherently different versus everything in this room. Even the blank space is a cube of something. Maybe there's a cube with no radiance, no color, no light, nothing, but it's something in the model. That's not with photogrammetry. And the limitation of photogrammetry is you need parallax, which you already need, you also need a NeRFs, but you need to like model a room. You're only going to capture what you got a lot of coverage at different angles of, or I think outside, versus a NeRF, it gets like everything. It gets the background, it gets perspective, there's no textures, it's those radiances. So reflectance and specularity, you don't have to manually do any of that. It's just trained into this representation. However, a mesh right now is much more useful in let's say creating a video game, creating a XR experience where people want to interact with an object. There's not really like a defined object in NeRF because everything is an object. You could say every little point in space becomes a little object. So you can't just like pick up a vase as a NeRF, but you could blend the two because now we're seeing them in you're starting to see NeRFs in like Unreal Engine. You could NeRF the woods or like a forest or a beach or something like that as your backdrop scene, and then you could put in photogrammetry triangle meshes that you want to interact with. But now I haven't had to, you didn't have to. I think of video games, you end up with like a sky sphere. You're like a sphere you're inside of, and then they've mapped the scene to the back of the sphere to make you feel like you're somewhere. Well, imagine if that sky sphere had parallax movement, reflections, all the things that you get in real world outside that you kind of miss when you do just like a static image. So you're able to kind of blend the two. But yeah, they're different. And a NeRF doesn't care about, at least early on NeRFs, it doesn't care about where an object really is in space. It's just trying to figure out what it looks like approximately. So, for example, if I were to look at a building, in fact, I have an example of this. I had a building I NeRF'd, and there was clouds overhanging the building, and I only saw the building from the front. And so then I took like almost a halfway turn. I'm almost looking from the side. And in the NeRF, the clouds are actually in front of the building, but we know they're actually way up behind it in the sky. But to the NeRF, it doesn't know where those clouds are, but it knows how to describe what they look like from the front of the building. So it doesn't matter where they are in space. They could be anywhere as long as there's clouds there and approximately where they would look like in real life. It doesn't matter. It's all an illusion. versus like photogrammetry, it's going to do its best to actually place that object in the right place in 3D space. But as NeRFs have also evolved, you're able to say things like, "Hey, I'm nerfing buildings." They could have a NeRF model that's specifically for outdoor buildings and say everything in sky should be really far away. So they could start to say in the model, put things back behind it to help it. But still, it's they don't care. It doesn't really care where those clouds are as long as it looks right. So that's the two differences. Is photogrammetry is really trying to get like accurate geometry and describe it in triangles. Another one's just saying, I'm trying to make it look correct to you. I don't care if it's correct, just to look right. So those are like the inherent differences, just how data is stored and how it's trying to render it in front of your face.
Awesome, great. Jonathan, what do you think will be the role of NeRFs and the effect of NeRFs in the future metaverse or metaverses?
I do think it's interesting as for world building. If you want, let's say the real world, not building a new world, I'd say the closest thing I've seen to NeRFs being used in a metaverse type application is through NVIDIA. They have not told anyone, or they have not announced anything that they're going to be putting NeRFs into the Omniverse. My hunch is they are, based off of how they talk about it. But they do have a simulator called Drive to Sim. I believe that's what it's called. Don't actually quote me on that. But basically, it's a driving simulator where you're able to drive through a scene, and then you have all these cars moving through it, and you're able to train self-driving cars how to better interact to randomness. And what they did was they took a NeRF from a real scene, and that is what you're driving through. That virtual self-driving car is driving through a NeRF, and then they used traditional 3D assets as all these moving cars and variables and people. And even in the NeRFs they've created, you're able to change the daylight. There's the recomposable NeRFs where you can change the appearance of a NeRF. So you can make it look like you're at nighttime, daytime, atmosphere effects, all those sort of things is possible. So what they're doing is saying, instead of spending thousands of hours of recreating this downtown area, like Block NeRF is an example where they took 40 square blocks of downtown San Francisco and turned it into a NeRF. Instead of trying to actually, you imagine the amount of time it would take to model downtown San Francisco. It takes a lot of time. And perhaps even someone has done it and you could buy it as an asset, but it'd be really expensive, perhaps. So you're able to just take a camera array on a car and drive around San Francisco and turn it into a NeRF. And then now you have this virtual world that appears to look correct. And then you could put it in a game engine, or you could put it in some metaverse architecture and then populate it with people, assets, whatever you want inside of it. And no one's had to spend thousands of hours creating this model of the city. So that's what I'm excited about it for. It's kind of that world building, and then being able to mix it in with, what we're used to.
Yeah, exactly. Content creation has always been a bottleneck in AR, VR, and these kinds of scenarios. But with NeRFs and also generative AI models that are trending right now, I think this obstacle is no more a pain. And as you said, you can just move around the block and train a NeRF to export a 3D of that block, which is awesome. But Jonathan, are there different types of NeRFs, or it's just one model and one type?
So that there's not like as far as my understanding is, there's no analogy of, let's say, file types versus how there's a GLTF, GLB, OBJ, all these different triangle meshes, and then there's PLYs, point clouds, have XYZ, all these different file types. But there is different NeRF models, and they are different. So there's no standardized NeRF right now, I would say. And I don't know if there ever will be, but there's also not like one standardized software or way that we do photogrammetry. There's different ones that are optimized for things. So there's a few. There's the most popular ones is Luma AI's NeRF engine. I don't know if they actually have a name for it. It might be the Luma engine. I don't know. Where they take images, they do something interesting in interim. They take a neural network and then they create a mesh out of that neural network. So it's a neurally derived mesh, and then it's textured. So they're able to kind of approximate a 3D model of the world using meshes. So you can easily put in a web viewer right now, which is really interesting. But then they also have actual NeRFs behind that as well, where they have the radiance values, and so you can do both. I think that's interesting what they're doing, and you could easily use that for making product
Jonathan, do you
configuration.
think it's manual or it's automatic? I'm judging from the time that it takes to from the time you upload and the time it creates the NeRFs.
It's all
Do you think
automatic.
it's manual
They
or
have
automatic?
they have no team at that company working on creating meshes. I mean, if they do, I'd be shocked. But my guess is that that's all automated. And I mean, even at the company we're at, our ethos is never have a team full of people with software trying to manually produce objects you can optimize. But that, there's that one. But then there was the original NeRF paper, which was slow, and then they've taken that and iterated on it many ways. So there's Instant NeRF, which is fast. What they've done is they've taken like the original NeRF paper and original NeRF quality and just made it much, much faster using called hash encoding and doing some other optimization tricks. But then there's a group at Berkeley has created a company called, they've created a project called NeRF Studio, and they have their own version of NeRF called NeRFacto, and it takes Instant NeRF and it then adds some other techniques from other different papers to make things like, let's say, in the background appear sharper. So there's all these different models. There's like a dynamic NeRF that's made for moving scenes. So now instead of having a static scene, can you imagine if you took 20 GoPros and you made an array, and then perhaps the best example I saw it was there was a student who acted like a bartender making a drink. You got like the transparent glass and the liquid and everything, which is cool. And they record it with 19 GoPros, and then as he's doing that little video scene, they're able to freeform move anywhere between those 19 GoPros, and everything just looks realistic. So you ended up with this really cool effect. You almost get you could almost do like a slow-mo bullet time effect with that, without actually having to have cameras between each little frame. And so that's one interesting avenue. And then I think the last one I would call out is NeRF in the wild, or this derivatives of that, where they're crowdsourcing images and then they're creating scenes. And I think that's a Google project. And obviously they're using that for their immersive Google Maps or Google Earth experiences that they're doing now. I'm pretty sure that's going to be behind it, where you can take images from all sorts of sources, recreate known landmarks. It removes people, it removes non-static objects, and then you're able to even change the lighting of it, things like that.
Mm-hmm. Awesome. So, Jonathan, what do you think will be next for NeRFs?
I just think they get better and more specialized. I think there's for specific applications, like you'll know which NeRF you'll need for what. I think there'll also be a lot more interoperability between game engines and animation tools. That's coming already. That's really gonna, I think, come. And then I think more productized. Right now, there's Luma AIs in a beta. There's really not companies that are out there that are productizing it. I think you'll see more companies saying, you can now use our NeRF for a fee, for a subscription, make them all you want, and they'll have better tools.
Awesome. So, Jonathan, as of our last question, what do you think will disrupt NeRFs?
That's a good question. I mean, it's so new; it's hard to think of it as being disrupting. In fact, I've been talking about this is what has disrupt old methods, right? So in architecture, what's disrupted doing hand sketches of architecture? Was it photos? Was it 3D modeling? Was it photogrammetry? None of them. They're still doing hand sketches. That's concepting. They're still taking like a picture and then sketching on top of it, or all kinds of things. So I wouldn't say necessarily be disrupted. There might be, I think, neural networks and hardware with neural, like tensor cores or neural engine cores will come on and make this stuff tangible to do on like a laptop or smaller devices. So I instead of just seeing it disrupted, I just think it'll just become another tool in a long tool set of visualization techniques for professionals and creators and machine learning scientists.
Awesome. So, Jonathan, where can our listeners find you and your contents?
Okay, so I am mostly active on Twitter. It's at John Jon Stevens Stephen 85. So I'm on Twitter. I post everything I pretty much do there, and then also on LinkedIn. If you look up Jonathan Stevens, I'm actually probably more active on LinkedIn. I like both communities because I like to talk to people in business. I like to talk to people in science, and they're in those two communities. And then I do have a podcast as well called Computer Vision Decoded. And then that's also all being hosted on our EveryPoint YouTube channel where you can find like my video tutorials. But if you find me on LinkedIn or Twitter, you will find everything else because I post those as I go.
So, Jonathan, thanks very much for joining the All Things XR podcast.
Thank you
It
for
was a
having me.
pleasure.